Friends, I believe when it comes to success, success is all about impact. Till now, we have studied about various tabular representations of data. So whenever we have a tabular representation, it's an ideal way to represent data in a systematic manner. But the same data, when it is represented pictorially or graphically, it looks amazing. And that is why it creates a strong impact, which is a very key aspect whenever it comes to taking it one level up. So in this particular section, we are going to learn about graphically representing the data in a very nice manner with these three tools. The first one being a bar graph, the second one being a histogram, and the third one being a frequency polygon. It is nothing great, but as I said, it's about creating impact. So the same data which we have tabulated till now, the numerical data in various ways that we had learned how to tabulate them, how to create distribution tables, we are going to convert those tables, we are going to convert this data pictorially to make it look more appealing. So first, let's learn about bar graph. A bar graph is a pictorial representation of a data in terms of rectangles. So basically, let me give you an example of students playing various sports. So first of all, we have a table out here. There are 4 sports, as you can see: cricket, tennis, football and badminton, and the respective frequencies, or basically the number of students playing that particular sport. Obviously, we are talking about a particular group, maybe students in a particular class. Now, as you can see, there are 27 students playing cricket. Naturally, cricket is the sport that we all love in our country. We have 9 students playing tennis, and then we have 18 and 12 students playing football and badminton respectively. Now we will learn how to draw or pictorially represent this particular data in the form of a bar graph. So now, as I said earlier, we have to draw an x-axis, we have to draw a y-axis. On the x-axis, we will have the different inputs. So basically, in this case, as we can see, different sports have to be listed on the x-axis, and on the y-axis, we have the number of students playing that particular sport. So we'll draw a suitable scale. Here, as you can see, 1 unit is considered as 5 students. So likewise, we have 5, 10, 15, 20, 25 and 30, because the maximum number of students for one particular sport is 27 out here. So there's no need of going beyond 30. So now what we have to do is create buildings, create rectangles over every particular sport, and the height here of that rectangle will represent the number of students playing that particular sport. And one thing that we have to keep in mind is we have to have the same width for every particular building or every particular rectangle, and the distance or the gap between 2 adjacent buildings or rectangles have to be kept constant as well. So the first sport, which is cricket, has 27 students. So here it goes, the first building, the first rectangle, it will go up to a height of 27 on the y-axis, and it has a suitable width here. This width has to be common. So moving to the next sport, which is tennis. Now tennis has 9 students. So let's raise this building out here, the second one. So the height represents the number of students. Likewise, we have football and badminton with 18 and 12 students respectively. So as you can see, we have created 4 buildings, 4 rectangles with equal width and with equal gap in between them, and the heights represent the number of students. So don't you agree with me? Definitely this is, the tabular form is a very systematic and ideal way to represent data, but when you plot it, when you pictorially represent it in terms of a graph, it's quite appealing. Anyone can say, oh wow, this is tennis and 9 students play tennis. So you can very easily understand the data, and it looks appealing at the same time. It creates an impact. So this is all about bar graph. Now we will learn about histogram. Now a histogram is nothing but a graphical representation of a frequency distribution table, with the width being the class intervals and the heights of the rectangles being their corresponding frequencies. So it's quite similar to a bar graph, but very distinct from bar graph at the same time. So let's take an example to understand what a histogram is. Here we have the class intervals, as you can see, 30 to 36, 36 to 42, 42 to 48, 48 to 54, and lastly 54 to 60. One thing that you need to notice here is this frequency distribution table is in its exclusive form. So as I said before starting this particular sector of graphical representation, make sure that whenever you have frequency distribution tables, always they are in their exclusive form, because then there are no gaps. It is always continuous and it is very helpful when it comes to pictorial representations. So this is already in its exclusive form. If at all a particular distribution table is not, make sure that you convert it, and we have already discussed how to convert an inclusive form frequency distribution table into an exclusive form group frequency distribution table. So here are the class intervals and their corresponding frequencies, which are 15, 25, 20, 30 and 10. Now let's draw the histogram. As I said, the x-axis and the y-axis. The x-axis going to have the class intervals and the y-axis is going to have the corresponding frequencies. Now the first class here, the first class interval is 30 to 36. Here we don't have information about what exactly this data is about, but it's just a general example, so let's consider it. So now, since we don't have any class before 30 to 36, what needs to be done is, at the start we make a kink. So here it goes, this is how it should go till we hit 30, because 30 is where we need to start. We don't have to worry about anything before 30, so just represent it with a small kink. That means there is something, but we don't have to worry about it because there is no data before 30. So the first building, the first rectangle is going to be 30 to 36. The second is going to be 36 to 42, 42 to 48, 48 to 54, and lastly 54 to 60, all adjacent to each other, all touching a continuous data. It is an exclusive form group frequency distribution. So now for 30 to 36, as we know, the frequency is 15. So this rectangle is going to have a height of 15 and the width is going to be same. Whatever it is, you have to be consistent with it. So now this is 15. The next one for the class interval 36 to 42 has a frequency of 25. Then the next one has a frequency of 20, then 30, and lastly 10. So as you can see, the histogram is quite similar to a bar graph, but again there is a vital difference between both of them as well, because this is for the exclusive form. It is a continuous data. The rectangles will have no gaps in between them, but the similarity here is the frequency or the number of students. In this case, the output is represented by the height of the rectangle. So this is how a histogram is represented. Now let me take another example which till now we are quite familiar with, the same example that we had taken, that we have rather been taking throughout, the example of those 25 students who are scoring marks between 0 to 50 in an exam on 50, and the scores, as we know, start with 8 and end with 48. Now for this particular raw data, we had created a frequency distribution table, and here it was, we had created the exclusive and inclusive both, but as we know, we have to focus on the exclusive distribution table. So here is the exclusive form of the frequency distribution table for this raw ungrouped data, which we had formed it into an array. Now it's time to create a histogram for this particular frequency distribution table. We will have an x-axis, we will have an y-axis as usual. For this, we would not need a kink because it starts with 0. The first class is 0 to 10. That means here we have the first class 0 to 10, then 10 to 20, 20 to 30, 30 to 40, and lastly 40 to 50. Now the first class 0 to 10 has the frequency 1. So here it goes, it will have a frequency 1. Now one more thing that we have to notice, that the highest value of the frequency in this table is 7. So on the scale, make sure that we have adequate place for 7 and we don't have to bother about it. So accordingly, we have scaled up out here. So the first class has 1, as we can see, a rectangle, a building, very small building out here. The second class from 10 to 20 has 7 students scoring in that range. So basically the frequency is 7. So the building needs to have a height of 7, as we can see. Then we have for the next class, the third class, a building of 6, then 5, and then lastly 6 again. So this is how a histogram is created for the same data which we had made a frequency distribution table, and mind you, it was in the exclusive form. So this is all about histogram with a couple of examples. Now let's learn about a frequency polygon. A frequency polygon is quite an interesting thing because it is nothing but joining points on a particular graph. So basically we have the XY axis, we will have a few points and we just connect it to create a frequency polygon. So as the word indicates, frequency polygon, frequency is basically the number of times a particular group is repeated. So basically the number of times a student, or the number of students for that matter, who has scored in that particular range. I'm referring to the same example of 25 students scoring marks between 0 to 50. So we will pull up the same example here, the same frequency distribution table that we have, again in the exclusive form. So for this, if you want to create a frequency polygon, you need to have certain coordinates for a few points which we are going to plot on this XY axis, as we see the XY axis, and then we need to connect them. What are these points? What are the coordinates of these points? Let's try and understand. There are going to be points which will have naturally the X coordinate and the Y coordinate. The X coordinate is going to be the class mark. For every particular class, there is going to be a point, and the point will have the abscissa, or for that matter the X coordinate, as the class mark of that particular class, and the Y coordinate, but naturally will be the frequency of that particular class. So the very first class, as we know, is 0 to 10, and by definition class mark is nothing but the upper limit plus the lower limit, the whole upon 2. Or as we say, the true upper limit plus true lower limit, the whole upon 2. But we know that for the data or the frequency distribution table in the exclusive form, the true values are the original values itself. So for the very first class, which is 0 to 10, the class mark is nothing but 5. And that is because 0 plus 10, the whole upon 2 is 5. So 5 is the X coordinate and the frequency is 1. So 5, 1 is the first point in this frequency polygon graph. So let us have it plotted out here. The y-axis again is going to have a maximum value of 7 because we don't need to bother about 7. The highest value of frequency is going to be 7. So 5, 1 is the first point that we need. The next point is going to be, as we know, 10 to 20 is the second class. So the 15 is the class mark of the second class. 10 plus 20, the whole upon 2 is going to be 30 by 2, which is 15. So 15, 7 is the second point out there. So we are plotting the second point there, 15, 7. Likewise, the third is going to be 25, 6, because the average of the lower and upper limit of the third class, 20 plus 30 upon 2 is 25, and the respective frequency is 6. So 25, 6 is the third point, and likewise we have 35, 5, and lastly 45, 6. So we have the 5 points out here, and then we need to connect all these points. But there is one more very interesting thing. When you connect all these points, it does not create a polygon. Why is that? Because it is just connecting points which are not closed. A polygon is something, a structure which is closed, right? Which has n number of sides, but it is closed, and this is not closed. So what to do in this case? There is one more important thing that we are missing, which I didn't discuss, and that is called as imaginary classes. What happens is, since we don't have a class with frequency 0 on either end, what we do is add imaginary classes. So before 0 to 10, there is going to be a class which is going to be minus 10 to 0, in fact, which doesn't sound natural because no negative marks are going to be scored out here. So the class mark of that class is minus 5, although we can consider 0 to be the class mark for that particular class, and the corresponding frequency is 0. So 0, 0 is going to be a point, but likely on the end we are going to take an imaginary class 50 to 60, for which the class mark is 55 and the frequency is 0. So imaginary classes have to be entertained here. So 55, 0 is going to be 1 point, and when you connect the end points to these new imaginary points, then you create a polygon which is called as the frequency polygon. So frequency polygon, as we just discussed, is nothing but connecting points, and these points are nothing but the class marks, comma, the corresponding frequencies of those particular classes. So we are going to have number of points equal to the number of classes with two added imaginary classes, with two added imaginary points, as to say. So we have here, in this case, we have 5 classes, so we have 7 points in total. Connect them and create a frequency polygon. Now on this note, let me tell you that there is one more thing which connects the two of the tools that we have just discussed, one of them being the histogram and the next one being the frequency polygon. Histogram and frequency polygon can be drawn on the same XY axis. So for the same example that we had taken for the 25 students scoring between 0 to 48, we can have the histogram and the frequency polygon on the same graph as such. As you can see, first we have the histogram. We had created the histogram earlier. Now if we plot the frequency polygon over this is how it is going to look. And in some cases, even this particular representation, pictorial representation, gives us ideas, gives us, for that matter, inferences which can be really very helpful. So this is how we close this section of graphical representation. Quite a good insight that we have learned here. We started with bar graphs, then we learned about histograms, frequency polygon, and ended with a combination of histogram and frequency polygon.